All right. So welcome everyone on live to Educational Chicken Prep. My name is Andie and I'm the zoology preparator over at the Denver Museum of Nature and Science. For those of you that don't know, a zoology preparator is the person that takes parts of animals, so that can be skins, skeletons, tissues, parasites, all kinds of different parts, and we preserve them for research in the zoology collections. So since I'm working from home, I can't really do my normal job with the wildlife that we find around Denver. But I thought today would be really interesting to show you all some anatomy and some skeletons of a bird that you see probably all the time. So this morning I picked up a chicken from the local butcher, and I'm going to show you a little bit about how chickens are shaped very differently from mammals, especially humans, what their muscles look like, what those muscles do, what their skeletons look like, and what the skeletons do. And we're also going to go over a little bit about what we do in the lab and how this type of chicken preparation is different from what we would normally do in the lab. So I'm just going to swing around, put on some gloves, and mount my phone so you can see what I'll be working on today. And then also, if you have any questions or comments, leave them in the comment section of this post. All right, so just give me a minute and then we'll get started. All right. So I have my handy dandy gloves here. It's really important to wear gloves, especially when you're working on something as slippery as a pre-plucked chicken. So another thing that I use to help with the slipperiness of the skin is our today's absorbent, oregano. Oregano is great for flavor, but it's also a dried up leaf, so it'll absorb some of that moisture. In the lab, we would normally be using some crushed up corn cob, but I don't want to eat crushed up corn cob because that sounds gross. So I'm going to use oregano instead as an absorbent. I also have a variety of knives. I have a nice small paring knife, a couple different size chef's knives, and some chicken shears that I may or may not use, and then a bowl for any kind of meat that comes off of this bird. So I want to start off by showing you what the chicken's skin looks like. I do love eating skin normally, but for this demonstration, I'll show you how I would normally skin a bird. But I want to show you really up close so you can see it. There's little bumps on the skin. For people, those bumps are usually like goosebumps. Birds don't get goosebumps, even though they're named after a bird. But these little bumps are where the feathers would attach onto the skin. So, and you can see there's some sections that don't have any bumps at all, and some that have a whole lot of bumps. And that's because birds have something called feather tracts, where the feathers lay in a certain place on the bird. And then eventually, when you get enough of those tracks, so there's two going down here, there's two going down the middle, and a bunch going down the legs, you'll get a bird that looks like it's completely covered in feathers. But in reality, they're just laying on these tracks. So when we're skinning in the lab, we normally go down the middle where there's a lack of feathers. So we'll do that right now. And that allows us to cut through the skin without actually cutting through any of those feathers. So you can see how easily and how thin that skin goes away. So I'm going to go, because we're not saving the skin on this one, I'm just going to go all the way up and all the way down. And you'll notice right here, I can show you a little closer. There's a little membrane that's attaching the skin to the muscle. And what I can do is I'll put some oregano down so I can pinch it. Put some oregano down. This is, again, our substitute for corn cob dust. And I can use this as traction and grip, and I can actually push the skin off and away from the muscle. And I'm just gonna say right now, this is probably one of the most satisfying things that we do in the lab. And it's super, super simple, super easy to do, especially on something this big. This chicken was about 2.5 pounds. And you can imagine when we're working on something much smaller, like a little warbler that's less than 10 grams, we have to be really careful when we're pushing that skin away. But in this case, we can just cut it off and it's fine. So I'm gonna cut off some of this fat really, really carefully to just get my chicken ready. I want to show you all what this muscle is. So this muscle is, it's a very light pink color. This isn't always the case for all the birds that we work on. Sometimes the birds are very, very dark red muscle. And if you've ever had like duck or goose, you'll definitely notice the difference between chicken muscle and duck or goose muscle. And the reason why that is because there's two different types of muscle. There's the fast twitch or white muscle, and then there's the slow twitch or the dark muscle, the red muscle. So you can tell just by the color of this muscle, this has a lot of fast twitch fibers, which means that chickens aren't necessarily made for prolonged movement and for flying very long distances. So we can infer, or we can make a hypothesis just by looking at the color of the meat that the chicken is not a very good migratory bird. It wouldn't be very good at migrating. And it really only uses these very strong, big muscles to fly away from something or to fly in very short bursts. So we can learn a lot about animals just by looking at the anatomy of it and looking at the bones or the osteology of it. And I want to show you the biggest bone on a bird. It's called the keel. So I'm just going to cut in here, cut as much of this breast muscle off as I can in one piece, because I am going to save all of this meat and eat it later, because I mean, it looks delicious. It's fresh from the butcher this morning. So I'm just going to cut off this piece of breast muscle, and that all comes off in pretty much one piece. I don't mean to brag, but like, I think this is a pretty good one. But you can see that there's two different muscles on here, right? There's this big one that was laying on top. This is the Pectoralis Major, and this muscle is responsible for the downswing of the wings. The reason why it needs to have such a big, big muscle right here for the downswing is because when a bird is flying, it's a force that's helping it fly is called lift. And lift is doing just what it says. It's lifting the bird. And it's lifting by getting underneath the wings and pushing up. So it's the air that goes over and then under, it goes up, pushing against the wing, and then it lifts the bird up. So when you have that really strong force that's lifting the bird, on the downswing, you need to have a lot of force as well in order to bring the wing down and get even more lift. So this muscle is the one that does that. The one that's underneath, this one right here, is called the Pectoralis Minor, and that one's responsible for the upswing. So it can be smaller because it doesn't need all that force that's necessary for it to come down as it needs to go up. So I just want to show you, now that we have this lovely fillet, we're going to put that in our bowl, save it for later. Maybe that'll become a nice roast. I'm going to clean this up a little bit so we can see the bone a little better. So just hang on with me one second. And we would normally, so when we're in the lab, we would normally be doing this type of work of getting all these larger muscles off first. Because we do need to save skeletal materials for research, it's really important to get a lot of this muscle off first. However, instead of cleaning it off completely by hand. We have our little helpers called Dermestid beetles or flesh-eating beetles. And normally when we're done skeletonizing a specimen, we would throw them into the beetles so that they can get fully cleaned and then wash them up and box them. Then they would go straight into the collections. In this case, I might just save the bones to make a nice chicken stock because that sounds really nice for some nice soup. All right, so we have the keel right here. Let me get off this other side just to make sure that we can see it pretty clearly. Bear with me for a second. All right. So now that one's off into the bowl. We have the keel. So the keel is, let me get to this side right here. It's a nice little protrusion right here. It's like a D shape. It's a modified sternum. So our sternum is sitting right in the middle of our chest and our ribs are attached to it. The same kind of goes for a bird. It's not too different there. So we have the keel here, and this one's pretty thin. And we have the ribs. Let me hold this up so you can see it a little better. We have the ribs right in here, and you can kind of see that. So it's the same kind of layout. It just looks a little bit different because birds are made to fly. A lot of the differences that birds have to mammals is a result of them being able to fly versus us, which are, we're stuck on land, unfortunately. So one of the big modifications for the adaptation of flight comes from this wing right here. So just like us, birds have a shoulder, which is right here on top. We have an elbow right here. We have a wrist, and then these are all the little hand bones. Let me just take off this wing so you can really see what's going on here. I think I need a bigger knife for this one. So, like I said, we have the shoulder that is connected to the humerus right here. Then we have the elbow, the radius, and the ulna, and then the little hand or the manus. And you can see that the hand part, when you compare it to my hand, if I can get this in the right place, it doesn't really have a whole lot of digits. It has really one here, and then a little modified thumb right here. So it looks a little different. And the reason why it's so different is because all of those bones that were in the hand have been fused together. And that fusion really helps the wings or the hand bones get really, really strong. So when you, if this were a bird that had all the feathers on it, this is where all those flight feathers would come out. And the flight feathers get a lot of strain and pressure from flying because, again, we were talking about those forces like lift that push on those feathers and tend to wear them out. So we have, you can see these little bumps right here. Those are the connections that, let me see, you can see, can you see the bumps? Yes, yes, you can see the little bumps here. Those would be where the feathers are attached, those big flight feathers. And these right here are the ones that gets the most damage when they're flying. So just think about like your hand like that, and then when it's pushed together, you tend to have more strength and ability to like push things down versus doing it like this, right? That's kind of the same concept that's going on right here in this hand. So we've got a wing. It'll make some nice fried chicken wings, hopefully. I'm not much of a cook, I will admit. Like, I can debone this chicken, but who knows if it's actually going to taste good in the end. So let's go on to another part of the bird that is modified for flight. We can go onto the back. So let me just keep skinning down. Just look at how wonderful this skin just comes off. This is beautiful. Just gonna cut through here. This is where the legs are. Look at that. So good. I'm gonna get some more oregano, AKA our absorbent for today. because my hands are slipping a little bit, but I'm very determined to get this chicken done. All right, so we got skin, skin. All right, so we're gonna take a look at the back. I'm gonna trim off some of this muscle, or some of this fat, sorry, back here, so we can get a better look at what that looks like. So you can see that the back is really nice and flat. This is because the pelvic girdle, or what's called the synsacrum, is fused together. So it's like if your lower back was all completely fused. For mammals, that's a really bad thing. That tends to lead to a lot of back pain. For birds, it's great because they don't need a whole lot of flexibility on their back. And you can see as I move this, the parts that are flexible are right here at the tail, right there, and then just above right here where that synsacrum ends. So from here to here, that's just one pelvic girdle. And if I flip that over, we can actually see there's some organs still in here, which is very exciting. I'm very excited about that. So I can show you guys some organs. I'm just gonna crack this open, sorry for the sound. So I can get a better look at what we've got going on in here organ-wise. Bird organs are pretty similar to mammals. They have a heart, they have lungs, they have all of that. The one that tends to trip up people when we're in the lab are the kidneys, and you can see the kidneys in here. So we have this right here when I'm touching with my knife, and all the way down here. So kidneys, unlike mammal kidneys, bird kidneys are lobed. So it trips up people a lot in the lab when I'm teaching them a little bit about anatomy. But once you get the hang of it, you can really see that this is a completely separate organ. And it works just the same as our kidneys. They just look a little different. But they're sitting right in this pelvic girdle. So if I push the kidneys away, pull them out, you can see that there's now like a little hollow area. The part back there, I think you can see that. Ooh. The part back there is completely solid, and that's a part of the pelvis. So it'd be like if we had just a giant bone on our pelvis, for our pelvis. It wouldn't be very comfortable for us, but like I said, birds, they work with it. They have that. It allows them to have a rigidity in their back that's necessary for flight. So again, it's one of those modifications that they have to allow for flight. A lot of those modifications, similar to the hand, either give the bird some strength. So the pelvic girdle is actually pretty strong, especially in birds of this size, or it lightens up the bird, because if it's flying, it doesn't want to add any kind of weight onto itself. So a lot of times that fusion can also lead to needing less bones, which means the animal would be lighter and allowed to fly. And this is kind of looking like a mess. I get that. But we'll go on to the next thing that I wanted to show everyone. Right here, we have legs. And I wanted to show people, especially some people that aren't very familiar with birds, what bird legs look like, because they are incredibly similar to ours. But it's just that birds have so much fluff from their feathers that it gets really hard to see the exact anatomy of a bird's leg. So when we get like a bucket from KFC, this is the thigh right here. So we have the pelvis here, and you can follow along on your own leg. We have the pelvis here and the connection for the femur. This right here is the femur. And then we have the knee right here. And the knee is usually inside like tucked into the bird. So we're not really able to see it. What we do see, usually when we see a bird walking around, is the leg right here. And then this cut right here is where the ankle is. So birds have, let's see if I can try to show you with these knives. Birds would have another bone going out here. So pretend like this knife blade is another bone. And then they would have another one for the foot. So this would be a whole ankle bone. And then the foot would start right down here. So it looks a little strange when you see a bird walking around, but for the most part, birds are built very similarly to us. Their only modifications come from the need to fly and strengthen up their bones, or strengthen up certain sections of their body for flight, or to lighten up their body, again, in order to fly. But overall, pretty similar to us, just some little things that are different. But yeah, that's pretty much it. If you have any questions, feel free to ask them in the comments once again. I think right now is about time to start answering questions.
I got you, Andie. Let me see. We do have some questions. I just popped in. Hi, everybody. My name is Memory. I work in the marketing department at the museum, and I'm just going to share these questions with Andie. We have some really good ones. Okay,
Ooh.
Andie, here's one from Talia. I've heard that penguin muscle is really, really dark in color. Is that because they need to be so fast and agile underwater? How would the tissue look in flightless birds that don't swim? Would they look like a cassowary?
Oh, that's a really good question. So penguin mussels are really dark. Actually, a lot of bird mussels are very dark. So if you think of ducks, those, they need to do really long migrations. So when we're talking about white mussel versus red mussel, they have a lot more of that red mussel because they need that prolonged energy for their flight. Penguins, similarly, they also do they have prolonged use for their muscles when they're diving and when they're moving around, but they also have to hold their breath for a very, very long time. So when you have those really dark muscles, sometimes that that dark red color can correlate with some with more myoglobin, which helps carry oxygen from the lungs to the body, and it's just more efficient. So when we look at most mammals and birds that dive, we see that really rich dark color in their muscle because they have to hold their breath for so long, and their muscles are just adapted for that prolonged time without breathing.
Awesome. So we have another question from Rachel who asks, do the beetles like eating a certain kind of mussel best?
Oh, that's a very good question.
Right? That is a good question.
They do really like mussel. I find that they don't really like ligament a whole lot, or tendons, so those harder tissues. But they like any kind of mussel, really. I find that they like mammals a little more than birds. The type of beetles that we have are found along the plains in Colorado, so they're not used to a whole lot of marine birds or mammals, so they tend to leave those alone. But they also really like bacon grease and bacon fat, just like anyone, you know. And I've heard that they also eat dog food, so I guess they're not very picky. They're not very picky eaters. They'll eat anything. Thanks for the question.
Yeah, we have another one from Monet. She asks, is fast twitch muscle inherently better for eating than slow twitch?
I don't think there's any that's inherently better for eating. I think where you're trying to get at is like people talking about dark meat versus light meat in terms of health. I find that a lot of the dark meat options like thigh and leg tends to carry a lot more fat, and that's just because the bird carries fat in that area. It's not necessarily like a caloric difference in terms of eating, but they do carry more fat around their legs and on their wings, just because that's where they tend to carry it.
Great. Okay, Andie, I think we have time for 2 more questions. We have another one from Rachel. She asks, what's your favorite bird you prepared?
Oh, that's a really good question.
Yeah.
Talia mentioned a cassowary, and I did do some cassowary. We did a whole neck. We did a neck and a head without the body. And that was really, really fun. It's so different, such an interesting bird. That one was definitely one of my favorites.
Awesome. Oh, this is an interesting one. Catherine asks, do chickens have a furcula? Furcula, am I saying that right? Furcula.
Yes, they do. And I can show you the furcula right now if we got some time.
Yeah, we got time.
All right. So the furcula is basically just the wishbone. So what you pull apart during Thanksgiving, that's what the furcula is. And it's the equivalent of our collarbone. So kind of like holds that area together, and it attaches to the keel, which is that big breast muscle. So let me just put the phone down so you can see the chicken. And I already took off my gloves, but it's okay. I can do it without gloves. But it's kind of hard to see because there's a little bit of muscle still on here, because I'm not a professional butcher. But you can see if I bring my knife through here, that's where my fingers are going through. That is the furcula. So that's the wishbone. It attaches all the way up here. And I can actually just take that off. And there it is. There's the wishbone.
Wow.
Yeah, pretty cool stuff. So yes, chickens do have wishbones as well.
Awesome. And I think that is all the time we have questions for, Andie.
Great. Well, thank you everyone for joining. If you do have a chicken at home, or if you want to grab one from the butcher, I definitely recommend it. And just go on and explore the chicken and just see what you can find. Maybe you'll find some gonads in there. Maybe you'll find more organs than I did. Just have fun. Hack away at a chicken. It's a great time.